We've learned the product, the quotient, and the chain rule. But what do we do if a problem requires more than just one of those rules? Well, I'm glad you asked that question. So the next three examples I'm going to show you have to do with using the product, quotient, and chain together. Not necessarily all three, but at least two of them together. It is possible to use all three, but we probably won't worry about that here, at least not in this video. So as you look at this very first example, try to think of the two rules that we're going to need to use to solve this. It's going to require the product rule because we're multiplying x squared times the square root of 1 minus x squared. And it's going to require the chain rule because inside of the radical we have more than just plain old x. We have 1 minus x squared. But one thing you have to figure out is what rule is really dominant. What's the main thing here? Which rule do we start with? Well, we're going to start this one with the product rule. And that's because only a piece of this requires the chain rule. Only the square root part needs the chain rule. The x squared doesn't. So product is our big picture one here. So we're going to call f x squared, and g, I'm going to go and rewrite it as 1 minus x squared to the 1 half. F prime then is 2x, and g prime is going to require the chain rule. So I do the derivative of the outside times the derivative of the inside. I'm going to go ahead and simplify that. 1 half times negative 2x is negative x. 1 minus x squared to the negative 1 half. So then I do f prime times g, and I get 2x times 1 minus x squared to the 1 half plus f times g prime. Well, I have x squared times negative x, so that'll become negative x cubed 1 minus x squared to the negative 1 half. And that would be my answer. Again, product is my big picture rule because everything there is being multiplied, but only one part of it has a radical that needs the chain rule. It was just the g, just the second half, that required the chain rule. Okay, let's look at this second example. We have y equals x over the cube root of x squared plus 4. So take a second and think, what two rules is this one going to require? It's going to require the quotient rule and the chain rule. Again, we need to figure out which rule to use first. Well, for a similar reason as the first one, we're going to use quotient first. Only a piece of this, only this denominator needs the chain rule because we've got something other than just plain old x inside the cube root. The whole thing doesn't need it, just the denominator. So that's how we know that chain doesn't go first because it doesn't apply to the whole thing. The whole thing is a fraction, so we need to use the quotient rule first. So f will be x, g will be x squared plus 4 to the 1/3. F prime is 1. G prime, we have to use the chain rule. Derivative of the outside times the derivative of the inside. Go ahead and simplify the 1/3 times the 2x and get 2/3 x times x squared plus 4 to the negative 2/3. So we do f prime times g minus f times g prime. So that's going to give me 2/3 x squared plus 4 to the negative 2/3, all divided by g squared. Well, if you square that 1/3, it just becomes 2/3. So that would be our final answer. Oh, sorry, I forgot the 1/3 right here. That's the final answer. Alright, last example. Y equals 3x minus 1 over x squared plus 3. So take a second and think what two rules are going to be required to solve this. This one's going to be the quotient and the chain. But this time, as you may have guessed, chain rule comes first. Chain rule is what dominates. And the reason is everything is being raised to the third. Everything is inside that power. So the whole problem requires chain rule, not just a small part. If you look back at these first two examples, only this half required chain rule, and only the denominator required chain rule. Whereas here, the whole thing requires it. So we need to start by thinking in terms of the chain rule. So we do the derivative of the outside, meaning we just multiply by the 3, and subtract 1 from the exponent, times the derivative of the inside. Now to perform the derivative of the inside, I'm going to have to use the quotient rule. Because my top is 3x minus 1, my bottom is x squared plus 3. So f prime equals 3, and g prime equals 2x. So we get f prime times g. I'm going to go and distribute this 3 and get 3x squared plus 9. Actually, I don't want to confuse anybody. Let's just do 3 times x squared plus 3. F prime times g minus f times g prime, all divided by g squared. Now, there is a little simplifying we can do on top of that fraction, so I'm just going to show the work for this down here. I'm distributing the 3 through, 3x squared plus 9 minus 2x times 3x is 6x squared, and then negative 2x times negative 1 is positive 2x, because we've got two negatives to make that a positive. So combining like terms, I get negative 3x squared plus 2x plus 9. So my final answer is going to be 3 times 3x minus 1 over x squared plus 3 squared times negative 3x squared plus 2x plus 9 all over x squared plus 3 squared. So that's how you use more than one rule at once. Again, it's really important to understand which rule kind of comes first. But if you look back at these three, I think you'll see the pattern.